Hey, my name is Caleb Cole, and I'll be talking about the MCR1 protein, its functions, and mutation R67C, which is arginine number 67 replaced by cysteine. The MCR1 is a receptor protein found in animals and is mainly located inside the plasma membrane. It is mainly found in melanocytes and immune cells, and its role is to regulate the production of eumelanin and pheomelanin, which determines the color and fur of a mice. The eumelanin and pheomelanin have two different roles. Eumelanin makes the fur darker, and pheomelanin makes the fur and skin lighter. The eumelanin and pheomelanin production is triggered by a hormone outside the cell, and is triggered and it signals the production um, the melanins inside the protein to go outside the protein into the cell. I categorize this protein as a receptor because it sits in the plasma membrane, receives hormones from outside the cell, and it triggers the eumelanin and pheomelanin production to go inside the cell. The MCR1 receptor controls the balance between eumelanin and pheomelanin when activated by the melanocyte stimulating hormone. This is to ensure that the mice have a dark fur coat. The mutation, which will be represented with this red pipeline, the red pipe cleaner, disrupts the signaling and leads to increased phenomelanin and reduced eumelanin. This results to lighter skin and lighter fur. The protein is found inside animals and is a transmembrane protein, and also the R67 mutation causes the protein to become less active. This is because the amino acid cysteine replaced the arginine acid position at position the amino acid cysteine placed the arginine amino acid at position number 67, which will be right here. And then the protein becomes less active because it doesn't bind to the hormone as effectively as arginine does. Without proper binding, the eumelanin isn't produced, which leads to more phenomelanin build up and alters the fur color, basically making the fur lighter. I made this model out of pipe cleaners, and the green pipe cleaners represent the amino acid sequence, and it's all interconnected, by the way. The purple represents the entirety of the protein, and the yellow and orange represents the cellular membrane. The red represents the cysteine, which is actually supposed to be smaller, but in this model it's not. Represents this cysteine side chain that is messing up the amino yeah. I used the original arginine group has a guanine group, which is polar, hydrophilic, and positively charged, but it's also very large comparatively to all its other amino acid groups. And this interacts through hydrogen bonding and electrostatic forces, which allows the hormone to bond to it easier. The mutated cysteine has a sulfur hydro group and is polar but neutral, and is smaller, which can form disulfide bonds, but it doesn't interact as strongly through charge. This is because the protein becomes less stable in that region, cannot bind to the hormone as effectively as it should with the cysteine group, leading to a reduced in its function. The change in its protein function means that it can't start eumelanin production properly, the melanocytes can't work properly, and the organism's fur is lighter. And some limitations with my model is that it doesn't really represent and respect the third dimensional nature of a protein, but it is for clarity and so you can understand this better without it being an enclosed protein. It doesn't show how large and small the cysteine and arginine are, because I have to show the mutation with this red pipe cleaner. It doesn't show how much smaller the cysteine group is comparatively to its other amino groups and the arginine group especially. And the protein, also the model doesn't show the dynamic nature of a protein, like how it moves and folds and interacts with water molecules and the plasma membrane properly, but it is just to make the concept clearer. And goodbye. Thank you for your time. I'm Caleb Cole, and yeah.